So in chapter 8, we're going to talk about things called rational expressions. A rational expression just means that you have a fraction that has a whole bunch of x's in it. We start with the most basic type, and that's called inverse variation. The equation will be y equals k divided by x. Notice you have a denominator that has a variable in it. That makes it a rational expression, but it's a special rational expression where we call it inverse variation. So we've done variations before. In chapter 2 and in Algebra 1, you did a variation called direct variation. And the equation was y equals kx. It was just like y equals mx plus b, but b was 0. So it's very similar in that manner. K was called, and it still will be called, the constant of variation. So if it ever asks you for the constant of variation, they're asking you to solve for K. Here's an example back from Algebra 1 and back from Chapter 2. Y equals 12x. The constant of variation would be 12. And there's an XY table for you. I thought it'd be nice for you to see what an XY table looks like of that stuff. So you can see like every time that it was like negative 12x. So if you plug in negative 2, you get negative 24. Negative 1, 12. 0, 0. 1, 12. And I'm sorry, I didn't mean to write negative 12 there. That was my bad. Okay, so every time you plug in the x's, you get out those corresponding y's. That's direct variation. Okay, let's take a look then at new. This is new to you in chapter 8. It's called inverse variation. Inverse variation is the exact opposite. Instead of like multiplying with 12, you'll take 12 and you'll divide by your x's. K still has the same name. It's still called your constant of variation. So there's your example. K is 12. Just notice instead of being times x, it's divided by x now. Okay, so it's, instead of k times x, it's divided by x. So I thought it'd be good if we made our own table. Let's do, so remember it's 12 divided by x. So what would negative 2 give you? What's 12 divided by negative 2? Good. How about 12 divided by negative 1? Negative 12. What about, and I did it already, but what about 12 divided by 0? Yeah, undefined, not possible. I'll write undefined. I like that word. And then what about positive 1? 12 divided by 1 is, and then 12 divided by 2? Okay. So it's really interesting to see it's not at all, look how much different the table is. It's not at all the same type of table. In fact, there's a lot of wonky things going on that one. Like we're reflecting, all kinds of cool stuff. Okay, so the first thing we have to be able to do is to look at a table and see, is it direct from like chapter 2 or is it inverse like chapter 8? All right, let's take a look at the first one, or neither. I put one of each on there just so you know. There's one of each. So here's our first table. In order to try direct, you have to, now give me just 1 second because this looks kind of confusing. To try direct, how would you guys move this x to the other side if I said, hey, can you guys get y by itself? You would multiply. So if you're like, that's not the direct equation, that is the direct equation. I just got k by itself. Okay, so what we're going to do is we're going to try all those y's divided by all of those x's. So I'll do the first one. I'm going to try 12 divided by 2. It's like slope. What's 12 divided by 2? What about, so that took care of those. What about 6 divided by 4? How about we just write not 6? If it's not the same thing, it's not direct. So I'm just going to say, nope, we didn't get the same thing, so we're done. Let's try inverse. Now, again, that equation might look kind of weird to you for inverse, but if I asked you to get y by itself, what would you do with x? You would divide by x, yeah. So you can see the equations there. I just isolated k. Okay, so let's do that for all of these numbers. So let's try the first y times the first x. What do we get? Yeah. And the second y times the second x, another 24. And that's going to happen each time because if you do the next y times the next x and the next y times the next x, each and every time you get 24. And some kids have said, once I see like the first 2 are good, can I stop? And the answer is, I mean, like maybe, but if the rest of them don't follow that pattern, then like you would be like, nope, not inverse. It's like a no relationship. So it is important that you do each one. So we can say that it's inverse The constant of variation is what we got each time, which was, what did we get each time? Up here in that box, that worked. 24, that's your constant of variation. And a function really just means equation. So it's y equals 24 divided by x. That's how you do those. All right, let's try the next one. 9:38. Okay, so I have 24 minutes. Okay. Let's try this next one. Let's try direct again. So direct is going to take each of those y's, like 1, and divide by the x. And that's going to make negative 0.25. I can do that one in my head. The next one's a little questionable in my head. The next one will be 0.75 divided by negative 3. Oh, I can do that one in my head. That's negative 0.25 as well. I think I can do all these in my head. All right, and then the next one's going to be 0.5 divided by negative 2, which is negative 0.25. And the last one is 0.25 divided by negative 1. So in case you aren't seeing it, it's every y divided by every x that I just tried. That worked. There's no need to even test for inverse. We found it. It's direct. This would have been a chapter 2 problem. So it says, does it fit direct? Yes, it's direct. The constant of variation, what did we get each time? Yeah. You can make that negative 1/4 if you rather have negative 1/4. It doesn't matter at all to me. So instead of your function being 0.25, negative 0.25 divided by x, direct variation is negative 0.25 times x. So I think there's a struggle that like the test for inverse is multiply, but the equation for inverse is divide. But that's why I want to make sure I did one of each. And then this last one, I told you I did one of each. This one must be a neither. Because if you do, let's try direct. If you do 40 divided by 0.5, you get 80 on your calculator. But if you do 12 divided by 1.2, not 80, I can tell you that. And then let's just prove that it's not inverse. I'm going to take all the y's and divide by all the x's. Does anybody know what 40 times 0.5 is? 20. And 12 times 1.2, you know what I know? It's not 20. So I don't even need to bother. It's not 20. It's like, I don't know, not 20. How about that? So this one's going to be neither. So there's no constant of variation and there's no function. It's not possible. All right. The next thing I need to teach you is how to develop an equation and then graph that equation. So it says y and x and y vary inversely. When you see this word inversely, think in your head that you're dividing. And x is going to be 4 and y is going to be 3. So it wants us to find the constant of variation, which really means find k. And in order to find k, here's what my brain does. I know that's my inverse equation. Y equals k over x. That was presented at the beginning. And then I fill in y and I fill in x. Y and x. And then I get k. So what would k be in this case? Good. Yep, multiply both sides by 4. So it asks us to find k. We did that. That's the constant of variation. What's the function? Y equals, has anybody caught on what you think the function might be? 12, but divided by x. Yep, 12 divided by x for inverse. It would be 12 times x if it was direct. And then an XY chart. So we'll get into more detailed XY charts in chapter 8, but for right now, you should only have a single x on the bottom. So just put 0 in the middle. And I made, okay, 1, 2, 3, 4, 5, 6, 7. I did 9. So 1, 2, 3, 4. I'll put 0 here. Good enough. A lot of students don't really know what to pick. And so we have 12 divided by x. You can pick anything you want. I tend to pick numbers that go into 12. Like, so I would pick like, 2, 4, 6, 12. That would be what I pick personally. You can pick 1, 2, 3 for all I care. Okay, but you have to be able to get a pretty picture. And I'm going, well, you guys are, maybe if somebody can plug those in, I'm going to get your calculator. I'm going to type it in so you can see what the picture is, like nothing you've ever seen before. So there it is, 12 over x. That's what it's going to look like. It didn't go through on your screen. Come on, buddy. There you go. That's what it's going to look like once we graph it. Kind of a weird little shape. We're not used to that shape. What happens if we put in positive 12? So it's like 12 over 12. 1. What happens if we put in 6? 2. What happens if we put in 4? 3. And what happens if we put in 2? Good. Now, again, you don't have to pick my x's, okay? But you do need to pick positives and negatives. So I'm just going to be maybe, and then this is going to be undefined. And that's why, see, like right here in the graph, let's see if I can touch the graph. You guys see this black thing? As it approaches 0, look, it goes all kinds of crazy. That's why, because it gets undefined at 0. All kinds of weird stuff happens. That's why it like looks so stupid like that, or cool. I think it's actually kind of cool, but you can pick any negatives. I'm just going to pick -1, -6, and -12. That'll give me good enough points so I can see what's going on. 12 divided by -1 is -12, 944. Okay. 12 divided by -6 is -2. And 12 divided, you don't have to pick mine. You just have to pick enough points that you get a pretty shape. All right, so I'm going to do 12, 1. Oof. I don't think there was 12 spots, but that's okay, unless I miscounted. There it is. And you can see that, hopefully you can see that shape coming into play. Over 2 up 6. So I can see this side kind of making that little funky shape. I'm just going to go ahead and connect. It will approach the x and y axes, but the x and y axes will be what we call asymptotes. So it won't actually touch your x and y axes. I also just like saying the word axes. Somewhere down here for that next point. I picked kind of wonky numbers. So somewhere over here. I have a pretty good general shape. I can also just do the reverse, like -2 and -6. There. That's what I like, using the calculator to verify my shape, and then I can get a couple of points and make it look like what the calculator was telling me it should look like. Okay. If you want to, like, as long as you have your XY chart, like if you want to for today, you can even just screenshot your calculator onto your answers. That would be fine. As long as you're able to get the X and Y points and plot them, and you'll be good to go. All right, let's keep going. Is that okay? All right, so I have I think 4 things I wanted to do with you. Yeah, I have 4 and then 1 tiny thing. So we're on number 3 already, so that's good. What did we say, 10:02? Okay. Now a word problem. Your math class, look how sweet we are. We pick up litter, good for us, each weekend, wow, at a local park. Every week, there's approximately the same amount of litter that's on the ground. The table shows the number of students who came for the first 4 weeks and the time needed. So I can see that as the number of students increased, what do you guys notice happened to the time that it took? Yeah. That's another neat way to kind of see that something's inverse variation, because as one goes up, one's going to go down. It has that little wonky thing it's not like a diagonal line. So that's one way to tell that something's inverse. If you see something's going up and something's going down, that's going to be a nice way to tell that it's inverse. And like the more people that help, the easier like work becomes. All right, notice that as the number of students go up, the time that it takes goes down. Find the constant of variation. So the constant of variation, if I want to go back up here, I'm not sure if I hope this is helpful. When we think something's inverse, we're going to do all the y's times all the x's. I'll say that sentence again. When we think something is inverse, which we do, we're going to take all the y's and multiply by all of the x's. So this will probably be something I should double check in my calculator. I see 85 times 3. I see 51 times 5. Does anybody have questions where I'm pulling those? I'm not like pulling them from thin air. Does that make sense where I'm getting them from? The table. And then 21 times 12. And 15 times 17. Now with word problems, we might not get 100% accuracy, but it's going to be, I think you'll notice it's going to be good enough like that we can say, like, yeah, that's pretty inverse related. We can use it like in general. 85 times 3. Oh, where am I at? 85 times 3. Okay, 255. 51 times 5. Okay, same thing, 255. 21 times 12. That might be a little weird. It is 252, but I'm going to say that that's good enough right now since word problems are where there's a little measurement of error there with like real life. Okay, so in general, I'm going to use 255, okay? And I'm going to say 252 is good enough to represent like an equation. Our equation might not be perfect, but it'll be good enough, okay, in general. So I'm going to write that k equals 255. And now for the function. Remember, the function for inverse was, do you guys remember, was it k divide or k times? Do you remember? K divide. And I'm going to fill that in. They don't actually want us to use y. They want us to use, what do they have for y? That's what, yeah, n's our x, and then, yeah, good. T's our y. Yep. So we'll do t equals our 255 divided by n. So time, and then you divide. I hope that kind of makes sense, like the time divided amongst the students. I hope. How long if you have 25 students? So what will we put 25 in for? Do you guys think we'll put 25 in for n or for t? For n, because it's students. So t equals 255 divided by 25. If anybody did on their calculator, please feel free to tell me. I think this was in minutes. Did you get it? That makes sense. Yeah, that makes a lot of sense. Like, okay, but so not too bad. Like, hey, if 25 people come, okay, not too bad. 25 students. Yep. How many minutes? Oh, look at this one. This one's a different question. What does 30 go in for? T or N? Yes, T. Very good. So 30 equals 255 over N. Now, how do we solve for N? Are you guys okay with this? We practiced this a little bit in chapter 7 when they're, yes. Good. Multiply N to 30. Excellent. And I can pull my calculator out. All I know is that it'd be 8 point something is my guess. What is it, 8.5? So I'm gonna, since we can't have half a student, I mean, well, maybe somebody's only functioning at like half rate, but I'm just gonna go ahead and say around 9 students. We already kind of said, like, our equation wasn't perfect. It was a good enough equation. So if we don't mind spending 30 minutes cleaning up trash, as long as 9 kids show up, we'll be at 30 minutes or under. All right, so we did the word problem. And now I'm going to talk to you about vocabulary terms. Sorry. I'm going to have different types of variation. So when I say combined variation, you might have multiplication or you might have division. Z varies jointly with X and Y. Okay, the word jointly means multiply. So let's get that let that be like a flashcard thing. So your equation for that will look like this. I always tell kids, here's what you do. When you read a math sentence, we're going to translate it right away. So I'll use purple because that sounds like fun. Here is Z. See the word varies? That means equals K. The word jointly means multiply. And X and Y mean X and Y. So there's your equation. I like translate it as I read it. So I can even spread that out a little bit better.
So wouldn't it just be Z equals KXY?
That's it. And then I was going to spread it out like that. That's where all of that came from. So yeah, and that will be good as you read a word problem. It's going to be all kinds of filler words that you don't need to even look at. So it's just Y equals KXY. And then eventually we'll fill those in and solve for K. But that's I call that the generic equation. That's a sentence in equation form. So the next one says Z varies jointly. I'm just going to write a multiply sign by jointly. And what do you guys think what sign do you think I'll put by inversely? Multiply or divide? Yeah. Okay, and then I'm going to change to purple, and I'm just, every time I see something important, I'm going to like translate it. So here's Z. The word varies means equals K. Jointly, so I'm going to have a multiply. What does it multiply with? X. X and Y are both multiply, but then divided by, what will I divide by? W. And then I'm just going to make that look a little prettier. I'm going to kind of join all that stuff up. So it's Z equals K X, Y, and then inversely with W. So that's just kind of like cleaning it up a little bit. I always put K on the top if you're wondering why I chose to put K. You could put K in the front of the fraction if that makes you happier. I personally always put it on the top. All right, let's try one more time. What do we have? We have a directly. What does directly mean? Do you remember multiply or divide? That's inversely. Yep, yep. And then multiply for directly. Yep, yep. And now I'm ready to translate. So Z, what does the word varies translate to? That's a weird one. Equals K. Then directly with X and inversely with, ooh, look, the product of WY. That's how we do the product of WY. That's kind of goofy, huh? So let's just kind of clean that up. And our nice little formula all put together is Z equals K. X and then W and Y are both inversely, so they both go on the bottom. So that's like mathy language. Now we're going to turn it into an example. Okay, 7 minutes. We can do this. Cool. If we get through this and we've done, then we're doing good. All right. You okay? The number, oh boy. Okay, here he is. The number of bags of grass seed N needed to reseed a yard varies directly with the area to be seeded and inversely with the weight of a bag. Whew. What that means is the bigger the yard, the more you need. However, the bigger the bag, the less you need. So I'm going to go find the important things. N is my number of bags. I see the word varies equals K. I see the word directly. That's multiply. I see the variable A, which is area. I see inversely, which is divide. I color coded it. I'm so proud of myself. And then no, I'm not going to answer that. And then the weight, that would be lovely. Thank you. And then the weight of the bag, since they didn't give you a variable, I'm just going to do W for weight.
Yeah.
I'm sorry I didn't have a variable for weight. I'm going to use W. Okay, so translate with not, yep, without the any numbers. So I see, I'm just going to look at my little red things. So I see N equals K times A divided by W. So I try to color code. Yellow goes with yellow, green goes with green, and then blue goes with blue. Now let's fill in our numbers. It takes 2 3-pound bags to seed that area. What do you guys think 2 goes in for? Or 3 or 3,600? We have an N, we have N, K, A, and W. N is the number of bags. So how many bags is in that? How many bags? 2 bags, so that goes in for N. This is a weight, so that will go in for W. And then this is an area, so that goes in for A. So what variable don't we have? K. And that's what we're going to do to solve. So I'm just going to do this, and then I'm going to erase my N, and it says that we need 2 bags. I'm going to erase my A. It says we have an area of 3,600. And I'm going to erase my W, and I'm going to put in a 3. And now we can use our algebra skills. How do we get K by itself? Multiply by 3. So multiply by 3, you get 6 equals 3,600K. Divide by 3,600. Oh dear. Is that 1 over 600? Math, enter, enter. I don't have my answer key on me, but I'm pretty sure that's, if we math, enter, enter that, that's 1 over 600. Sure? Okay. All right, I'm just going to roll with it. Usually I check with my key, but I think we're good.
6 times 6 is
Yeah.
36.
So 1, yeah, we're good, we're good. So we're going to fill the equation in, but only with K. So K is 1 over 600. W, A, and N. That's how you fill in K. And now we move on to what the problem asks. How many bags? So we have our 1 over our 600. What does 9,000 go in for? Uh-huh. What does 3 pounds go in for? Yep, good. And then the question was about, oh, you even said it and I didn't write it. Sorry. Now we can solve for how many bags we need to buy. So that's 9,000 over 1,800. What is that as a decimal? Is that a decimal? I don't know if it's a decimal or not. Oh, it's a clean cut 5. What if we would have gotten 4.3? How many bags? If we would have gotten answer 4.3, how many? That's right. Good. That's right. There's a problem about carpet in your homework. The last thing I wanted to do, we don't need to, this is the same thing, but this one, I just wanted to see if you could go backwards. What would the sentence be? P, what does equals K mean? Yep, P varies. The product. Yep, you guys are getting it. What's the product of Q, R, T, Q, R, and T. Inversely. Okay, we made it through. All right, good.